Welcome. So we in class investigated a couple of multivariable functions and we came up with traces and contour plots of those. Now I'm going to take a look at uh, some of those same functions, only this time looking at using online technology to be able to graph them. So right now I'm in D2L under the Course Content tab. Here under the heading Course Information and Resources, I have a link to online technology resources. Here there's a long list of different free online graphing applets. I'm sure that there's one that you might like. That I'm going to look at a couple of them today. So the first one that I want to look at, and actually I think I want to open it in a new tab, which is covered. Sorry about that. So let's take a look at this one that's good for traces, opening it in a new tab. It gives us a little more space to take a look. So this is the default graph that it comes with, some hyperbolic sine graph. Let's look at the graph that we were talking about before, x squared plus y squared, and see if we can visualize those traces a little better. So here's an image of the graph with a mesh representation. And I can spin this around to take a look at it from different angles, which is a nice feature. I'm going to click on X, and this is giving me just my traces, my vertical traces, where X is equal to a particular value. And as I turn this slowly, maybe you can see it traces out those parabolas. The parabolas that we saw before that we were drawing at the chalkboard are now visually present here. And I can click on Y, and this gives me the parabolas in the opposite direction, the vertical traces where my Y values are set equal to a fixed value. So this does give us an idea of exactly what this graph looks like, but unfortunately this grapher doesn't, although it gives us good pictures of the vertical traces, it doesn't give us a good image of the horizontal traces or a contour plot. So let's go back, and I'm going to use a different 3D grapher that's better for contour plots. So I'm going to open this link in a new tab, and let's take a look here. So this is a 3D and contour grapher, so it can give us some contour plots. Remember that contour plots are made out of level curves, and those level curves are exactly our horizontal traces. So let's input the function that we want to look at, x squared plus y squared, and click graph. And notice that it gives us a set of level curves. It's color-coded so that green contours represent lower curves and red contours represent higher elevations. One of the things that it will default spit out the values that it wants to give you for its z values for the level curves. So for example, if I wanted to see the level curves where z was equal to 1, 2, 3, 4, and 5, I could set that and click Custom, and now I just have these 5 level curves. This is more similar to what we were investigating in class. Notice that the level curves get closer and closer to one another as you radiate outwards, which is representing the fact that in a smaller amount of distance in the xy plane, the z values are changing more rapidly. Another option that this online grapher has is that I can toggle between 3D grapher and a contour map grapher. So clicking this button down at the bottom, it will give me, it changed the function on me. I can change this to x squared plus y squared and graph it. And now here I'm getting the graphical readout, which I can turn in 3 dimensions to be able to examine. And notice that the lines here are exactly the vertical traces that we saw in the last graphing program. It's just representing both the x and the y vertical traces simultaneously, which gives us this grid pattern. So this is just one exploration using 3-dimensional software to be able to represent these figures graphically. In your homework, you'll have the opportunity to explore a number of other different classic examples of multivariable or 2-variable functions that you're going to explore using 3-dimensional graphing software. Thank you so much.